Ho ho ho, mathematicians. It's the Merry Kris-Math live stream. What does that mean exactly? Nothing. It means I'm doing my live stream on Christmas Day. And we will get back to Lean. I haven't actually quit Lean. And in fact, Arad messaged me on Discord like immediately after stream with a suggestion, an easy suggestion how to fix things. So we will get back to that tomorrow. But in the meantime, I figured I don't know. It's Christmas. Let's take a break. Let's do what one does on Christmas and look at some archive papers or what else are we? Yeah, go on Reddit or I shouldn't have. I forgot to pop out chat. You will not marry Chris. That's what you think. That is what you think. Guess we'll see. I guess we'll see what time has to tell us. You know, you're in the chat of my live streams an awful lot for someone who's not trying to get married. So think about it. Merry Kris-Math to you too, Christian. Merry Kris-Math to you too. Let's celebrate by seeing if did anyone publish a Christmas Day paper? That would be great. Parameters and theta lifts. I think I took a look at that the other day. Definitely seems interesting. Yeah, I guess not a ton has happened here. Not a ton has happened here since the last time we visited. Let's see what's going on in finite groups. Let's go see what Math Reddit is up to. This is interesting. Actually. Hard to tell if this is real or not, but they say they're at an R1 university in mathematical statistics, and they say they've basically gotten papers in top journals by using AI. What I find strange about this is it really seems that AI is just good at finding things. And so yeah, I don't know. Yeah, maybe their field is such that you can stitch together a lot of existing results in order to prove some theorems. I don't know, because you know what, I actually was using I decided to buy a month of Jippity Pro. Actually, I think I accidentally bought some ripoff site called Ask GPT. It wasn't it's not Chat GPT. So that was stupid. You know, it came up earlier in one of the searches. So I just clicked on it and it looked like Jippity, but it was Mari Povich to you too as well, or Bill Murray to you. Anywho, but I actually was using it. I was asking it questions about the stuff I'm trying to figure out about equivariant sheaves. And it did actually, there were some ideas I had that I just figured out on the plane ride over to Winnipeg. And then, and then this Jippity clone was telling me exactly those same ideas, and I was like, okay, damn, that could have, would have saved me a little bit of time, if I had asked it earlier before figuring it on my own or something. Shouts out to Equivariant Chiefs. Amen. Amen, brother. But of course, then I followed up the question and I said, "Hey, can you point me to some sources on this material? Because, I had done a bunch of digging before. I hadn't found anyone dealing with the specific thing that I was dealing with, right? But then it was able to produce, sources that it was getting this stuff. So, so it still just seems that they're just a very, very good search engine. And so I wonder, like, this guy's publishing in top journal, but are a lot of these results just not like known things or what? I don't know. Generally avoid LLMs as a principle, but it was useful a few times when you couldn't find a paper and couldn't remember the author's name. Yeah. Yeah. That's something that's good for as well. So I don't know. Is this real? That's another question. Is this real? Or is this guy farming Reddit karma? Is this guy farming I don't know. The reason you don't use LLMs that much of math is because it's factuality issues. What? To the extent you use it, it's more for overview and advice. Yeah. Hello, the duck with a monocle. Merry Kris-Math to all, and to all a good day. Doing math. It makes shit up all the time. Yeah. I don't know. I feel like it's gotten better, to be honest, the more I've used it lately. But I don't know. Yeah, this person also says, I find this very hard to believe. I've used AI in my research. No, I do find it to be a useful tool. It's not capable of producing a proof sketch for a typical lemma in my papers. And certainly not a main theorem. Yeah. And certainly not in good, top journals. Yeah. That's something that's suspicious about this person's post. Yeah. 90. Yeah, I also give it about 90% chance of being made up. Yeah. Yeah. So I don't know, but maybe I don't know. Does it not? Does it just not take a lot to publish in a top journal in mathematical statistics? That's what this guy's field is allegedly. So yeah. Yeah. Unbelievable story written by ChatGPT. Oh, interesting. Hidden account and no interaction from OP. Yeah. Interesting. Yeah. Very curious. Hello, Ashif Khan. They have math symbols on the right? What do you mean? What? Who has math symbols on the right? You mean over here? Yeah, this is probably made up. Yeah, it's got the bullet point list. I know, so that's usually a telltale sign that it's AI. But I feel like I think an interesting thing has happened now where like I think it's turned around and to the point where AI is influenced writing. So like actually last winter when I was grading for an Algebra 1 course, that was one of the dead giveaways that I knew students were just copying and pasting from AIs, one that had these bullet point lists, among other things. And I was just instantly like, okay, these kids are dumb. But I do think I've seen I do think I've seen it more from legitimate sources, and I think there's this feedback thing that's happened where it's like people are doing it now because of AI. You know what I mean? Like they've picked up that habit from AI. So yeah, wondering if this post itself had a yeah. Oh well, that wasn't so interesting. I guess it turns out it was an interesting talking point nonetheless. Maybe you just got better at looking out for it. Yeah. Whoa, this is a crazy post. This person has no idea what they want to do. Langland's non-commutative geometry, I mean, those are kind of related. And homotopy type theory, I mean... Mind you, someone should formalize Langland's in hot, right? Why can't that someone be me? It seems like it's going to be this guy instead. Yeah. Yeah. Exactly what that person said. And they give no other information about what their background is or anything. Yeah, exactly. Yeah. Okay, let's see. Let's see. Oh, and then OP. Oh yeah, so this person's like, "You're mean. You're being too mean. People are mean sometimes." And then OP, and then this person responds again, saying that what they're trying to do is literally insane. And then OP was like, "Actually, this was the best comment." Yeah. Oh wait, no, maybe they. Oh, never mind. No, they were responding to Quasar person. Uh, yeah, I don't know. Non-convex baking goods. Isn't that pretty much what we all want to do? Well, fair. I guess that's fair. Is a good career after a math degree possible? If you do applied math. If you do applied math, then yeah. Or if you're a genius. Yeah, define good. Define good. What do you mean by good? That's different for everyone. Yeah. Yeah. Yeah, what is OP even trying to say here? You could go from linear algebra through these fields with self-study. Yeah, take over a decade and a half. Does this mean that trying to study these subjects independently is nearly impossible? Yes, it does. Okay. Well, they've got complex analysis and real analysis and stuff. And they're just starting abstract algebra. Yeah. Still. I don't think it's simple. Yeah, okay. Okay. Whatever, I'm bored of this post. Money. Well, then you should do applied math. And work contentment. Well, I don't know. I don't know about work contentment. That's also highly that's also highly personal, you know. What contents you about work, you know, what would make you content with work would not necessarily make me content with work, and vice versa and stuff. Oh, I gotta cut my beautiful face off with this desk. We don't wanna slice any faces off on live stream. Okay, let's see. What's going on in finite groups? I always find something cool in finite groups. Why are we talking about symplectic forms and Lagrangian submanifolds in finite groups? Because it picked up on. I see. It picked up on homology group. Zariski topology and cohomology for commutative gamma semirings? Ooh, Maple Leaf. Maple Leaf. That is homegrown Canadian mathematics, baby. We're asserting our independence by, you know, publishing our own math these days. Oh, holography with ADE singularities. Yes, please. Yes, please. Operads, modules over walled Brouwer categories and Koszul complexes. That also seems interesting. I don't know what that has to do with finite groups, but it seems interesting. If you search finite groups with quotations... Oh, I see. Yeah, I guess that's what I want. Oh, wait, what's this? Some cohomological properties of P groups and non-inner automorphisms with order P on non-abelian finite P groups. That also sounds cool. See, I always find cool stuff. Well, we already found 3 cool papers. Let me go get some coffee so I can actually read these. Gotta advertise my p-adic hat as usual so I can afford gifts from Santa. He started charging a delivery fee in my country. Damn tariffs. Damn tariffs from the States. Okay. Let's take a look at this. Holography. We study aspects of ADS CFT. It's a finite group leading. Yeah, so I always see this finite group in SU2, and maybe that's because of ADS CFT stuff, but like what about other finite subgroups of Lie groups and studying like quotients of stuff? You know, is there some AD, could one expect some ADE like classification of singularities there? Oh, this is way more physics than I was expecting. I don't understand anything that's going on. Oh yeah, this is too crazy for me. Goodbye. Operads, modules over walled Brouwer categories, and Koszul complexes. Certain complexes that are associated with an operad in K vector spaces where K is a field of characteristic 0. This exploits the study of modules, blah, blah, blah. I have no idea what walled Brouwer categories are, but whatever. Um, surprise physics, yeah. Yeah. Some physics is okay. I actually love tons of physics, but I was referencing in my mind uh, I was referencing no, come on. Yeah, some garbage is okay. Yeah, in my mind I was referencing this clip from what uh um Eric Andre. That's the show from Eric Andre. You're back. You were gone at least 15 minutes. Wait, were you? There's no way. Time doesn't move that fast. I'm also not so sure I understand what's going on here. K vector spaces. Eh. Oh, you know what? I just got an idea. I just got an idea for an ask GPT. Let's do some I want to read this other paper first. But I got an idea for some how do I start a new conversation? How do I have an idea for a new thing I want to ask it about the Gaber reconstruction theorem. Yeah, let's go check that out afterwards. Let's see what Jippity will tell us there. Okay, some results on cohomological properties of P groups and non-inner automorphisms with order P on non-abelian finite P group. Intriguing. This was started by Wolfgang Goschitz. My German's terrible. Had proved that any finite P group of order at least P squared admitting outer automorphism of order P in 4. Wait, what? Does this sentence make sense? Hang on. Admits a. Wow, this is a terrible type. Hey, I shouldn't be one to talk. I realized that my abstract and introduction in my most recent preprint was actually not good, and I'm still trying to make it better. Whoa, wait a second. Is this a ChatGPT paper? Hang on. This is sauce. Look at this bold sentence with a lowercase w. What are we looking at here? A non-academic email? Okay, this is extremely sus. Okay, the rest of it looks kind of normal. What is this, though? I've never seen this notation in my life. Maybe it's extremely common notation. I'm pretty sure it's been an eon, actually. 1 eon. How long is an eon, actually? Petition to swap eon and elon. Gone for 50 light years? That doesn't really make sense. Hey, do you guys remember when Star Wars didn't realize that light years was a unit of distance, and then they, they wrote a whole movie to try and make it to try and explain why actually it made sense in context? Yeah, that was fun. 1 billion years. Eon or aeon. Okay. Yeah, it was parsecs. Right, it was parsecs. They made the Kessel run in 3 parsecs. It's been 1,000 tons since I've been here. Oh, yeah. Man, we haven't looked at archive together in milliliters. Interesting. Okay, the rest of this paper looks normal. The rest of this paper does look normal, to be honest. Yeah, Aeon does feel Lovecraftian. I agree. I mean, a billion years is pretty Lovecraftian. It's a Lovecraftian amount of time. Okay, the rest of this all seems normal enough. So maybe I was just being rude earlier. Yeah. Okay. Let's see. I mean, here it does say they're from a university, but I guess. Oh, maybe that is a university email address. Okay. Okay. Let's see. Let's go. After this, a natural problem was posed: whether any finite p group with order at least p squared has non-inner automorphism p. From the main result in for an abelian p group with order at least p squared. Yeah, I mean, now I kind of feel bad. It could just be a language barrier thing. Are the references real? I think I would bet so. I'm now I'm pretty sure it is real. Now I'm pretty sure it is real, but yeah. Yeah. I am also weirded out by this upside down omega, but whatever, maybe that's common notation. Inner automorphism. Has a non-inner automorphism of order p. Since the outer automorphism group of an abelian group is isomorphic to its automorphism group, the more precious description is whether any non-abelian finite p group. Yeah. What is phi g? What is phi g? I have no idea what phi g is. Yeah. Am I real? No, I've been AI from the start, and you should feel pretty bad about yourself that you are, you've been hanging out here this long and you still haven't figured out that I'm not real. Yeah, there's upside down omegas later on. What is phi g here? I don't know what that's supposed to be. In this paper, we verify the answer to the above is positive. Specifically, theorem 2.5 will be proved, and there's no link. Well, yeah, and what does omega 1 here mean? What does z is? Okay, so the omega 1 of the center. What's omega 1? Yeah, I gotta say there's some definitions here. Omega 1 is all of the, so it's not elements of order p. It seems like all of the elements where you put them to the power of p are 1. So a strictly bigger thing. Where is the drink? I already drank the drink. Actually, I had some purple drink. I already had some purple drink, so I'm flying, and now I've got this other purple drink. So, yeah, where it's a magical Christmas morning over here. In section 5, we use cohomological properties proved to get the special result. What's a special subgroup? Yeah, the thing is, there's a lot of undefined terms in this opening. Maybe they're defined throughout. Maybe you could say the same thing about my papers. I don't know. Yeah, of order. Oh, of order dividing P. So, right. You're right. I guess it is elements of order P. Yeah. Well, Boris, actually, non-inner is maybe a good term, right? Because sometimes, yeah, no, I guess you should call it outer. But I mean, I could imagine sometimes an outer automorphism means an element of the outer automorphism group, which is actually, an equivalence class. Yeah, I don't know. I don't know, man. There's going to be undefined terms in any introduction. Yeah, that's true. Yeah, that's true. It's just my unfamiliarity with the field. But, I mean, it does seem... Yeah, okay. But then are there... Okay, I guess we're defining some of these terms here. Yeah, I don't know. Is this just a matter of the... Is this a matter of what... Like, terminology of the field I'm unfamiliar with? Because, like, what was... Phi G wasn't defined, was it? But maybe that's a pretty normal... Maybe that's pretty normal notation in group theory I should be familiar with. Yeah, and where does this come from? I'm so curious about upside down omega. Yeah, I don't know. Phi G was defined in the notation part. Okay, that's on me. That is on me then. Oh, the intersection of all maximal subgroups of G. I see. Non-abelian. Yeah. Upside down omega does go crazy. Yeah, I kind of want to find an excuse to use upside down omega now. It's agemo. Agemo, yeah. Agemo of Z. Mod by agemo of Z, yeah. Yeah, I don't have a Santa cap, actually. I mean, in theory there could be one around here, but, good. Good, Boris. See if I care. Unsubscribe for all I care. You'll come crawling back. I know you will. I know you will. Okay, let's see. There's some cohomology going on here. That's what I wanted. That's what I came here for. I came here for cohomology. So we got this extension, chapter 2 of 12. I wonder, chapter 11 of 12. Set this to this. So omega 1, right. So this is H1. This is H1 of the G mod N. We're taking values in the group of elements of order P in the center specifically. Interesting. What? A murder is an extroverted suicide? Did I miss something here? Oh, disliked is really just upside down liked as well. Yeah. Or is it a reflection or is it a rotation? Is it a reflection or a rotation away? I see a lot of familiar terms yet don't understand anything. Welcome to mathematics. Yeah. So I do kind of want to just write papers where I prove things about H1 and H2 telling me stuff. I'm kind of intrigued by it, honestly. Maybe many months in the future I can tell you guys about some interesting stuff I've been thinking about to do with that. Yeah. Oh, the Jacobson radical, yeah. Yeah, I don't know how much I'm gleaning from this paper at the moment, but cohomological results of P groups. Let's take a look. I got some bounds on the cohomology. What else we got going on here? However, glance at Machizuki's 3 papers on stream. Well, actually, I believe it's 4 papers, and that's just the official proof of IUTT. You know, it depends on a whole bunch of work that he did before. So no, I've never opened up those papers on stream, but I've thought about it. I thought about a series where I try to read through some Machizuki, but I mean the truth is it would take like an expert in abelian geometry a long time to get anywhere like non-trivial. So G module without the hyphen is chaotic evil. Yeah, I guess so. Don't read Machizuki's papers on stream. Yeah, probably not the best idea. Okay, I do actually. Let's ask Jippity this thing. So, how do I start this conversation? Because I want to ask about Gaber reconstruction theorem for quasi-coherent sheaves. Suppose I have a commutative ring R. How can I describe the automorphism class group of the category? Can I even spell anymore? Is that, wait, no, that's wrong. Oh my god. Category of R modules in terms of the automorphism group of R and the Picard group. You obsessively avoid hyphens and dashes now. Interesting. Why is that? Semicolons are sus too. You know what? Why even use punctuation at all, for that matter? Font for me, ChatGPT wrapper. What? Even commas will get it if they don't mind their business. Christian, what did you post? What's that? Is that snow woman blowing wind? What's going on? Oh, how do I zoom out of chat? Oh no. How do I make chat zoom out now? Uh-oh. I zoomed in, but now I can't zoom out. Certainly a control minus will do this for me. Okay. Okay. But now we're in the wrong... let's just reset. Yeah, there we go. Oh, farts were requested. I see. Twisting by ring. Okay, let's see. You want to describe the group of autoequivalences of this category in terms of this. Sure. Sure. Let's see the structure of this. Key fact for commutative ring: every additive R linear autoequivalence of mod R is naturally isomorphic to a composite. More precisely, we have there's a short exact sequence. Yes. Right. In fact, it should be split. Right? This map should be split. Oh, and they have I wonder if this is right. Yeah, how do I get it to render tech? Well, that's partly because this is a cheap ripoff, a cheap knockoff. Yes, I am modding my automorphisms to get automorphism classes. Yeah. Am I LaTeX? I think so. I feel like it sometimes. More precisely, yeah, okay. Let's see. So, the map from here to the automorphism group is obtained by looking at the induced action on the endomorphism ring of the unit object. Is that true? The kernel consists of exactly those Wait, is that true? Because I tried. I had that thought before. But oh, you asked what am I modding by? Equivalences of isomorphisms of functors. So the objects of the group are isomorphism classes of functors under natural transformation. But I had this thought before because so somehow we want to get from an automorphism an autoequivalence, let's say an isomorphism class of autoequivalences to the let's even forget about the classes for a second. Let's just say we're taking a full automorphism group here, and I guess we also have to impose R linear. Is that true? Because we could have a non-R linear equivalence, but every equivalence is an exact equivalence. Anywho. Surely you want your self-equivalences to be monoidals? I have no idea what you mean by that. TBH. So then the idea, let's just suppose we have some autoequivalence F, and we want to obtain a ring isomorphism. What do? We go R, and then we take the isomorphism with HOM RR, and then we take the isomorphism to HOM FR. But then the problem is, like, if we get back, so I was trying to think, how do we get back to R? And I was thinking we would use maybe, like, we can promote the equivalence to an adjoint equivalence. Now we got to be worried about, well-definedness or whatever, but so if we promote it to an adjoint equivalence, then we could make it isomorphic to this, which is isomorphic to this, and then by our natural transformation, it's isomorphic to this. But I thought when I wrote this out before for myself, I love you too, Adam. Merry Kris-Math to you. I thought when I thought when I wrote out this equivalence before, I convinced myself that this always actually just gives you the identity map on R. You don't actually get a non-trivial automorphism. Maybe I was wrong, but I'd convinced myself of this. Well, that's the question, Leo. That is the question. AI is telling us, I think essentially this is, which is what I had thought before. I don't think that's true. Oh, you mean monoidal functors? Oh, I see. Um, well, maybe. I think that's also an interesting question. I mean, definitely, if you want to do some sort of Tannakian reconstruction, blah blah blah, then you definitely want monoidal something. But um, I'm interested in the more general question. Because as a monoidal category, mod R is compactly presented by line bundles. What does it mean to be for a category to be compactly presented by line bundles? Hence the Picard group. So it's like saying the automorphism is determined by its action on generators. What is... I don't know what that actually means. Probably random question. How do you know short exact sequence is right or left exact? Well, short exact sequence is a short exact sequence. And then tensoring is always right exact. It's always, we'll take it to tensoring is a right exact functor, and so you'll always end up with potentially shorter sequence if you tensor this by M, you'll get this. This will be exact, and then if you want to know if it's still exact with the 0 here, then you got to check. You just got to compute it. Oh, sorry, or were you asking how to prove this statement? Yeah. Merry Kris-Math to you, Maknubi. Merry Kris-Math to you. Even your Google queries are becoming ChatGPT questions. Yeah. Well, let's go compact objects. Finally presented, blah, blah, blah. Certain finite conditions. It is compact if Hom functors commute with filtered colimits. Okay. Okay. What does that mean? Terminology is motivated by an example arising from topology below. Okay. Oh, wow, great. Infinity categories is an example. Thanks. I spent 8 hours and I know nothing about them. Compactness and triangulated categories. This is probably something I should know about, but I don't. Okay, here's one that we care about. For ring R, compact objects in the category of R modules are finitely presented R modules. In particular, if R is a field, then compact objects. Okay. Okay. Well, what does it mean to be compactly generated? What does it mean to be compactly generated? What does it mean for a category to be compactly generated? Okay, what does AS say? can be build up any object as a filtered colimit. So any module can be, you're saying, Arad, that any module can be written as a filtered colimit of invertible modules or whatever. Go to examples. You go to examples. Oh. Compactness is about smallness. I mean, I totally believe that on vibes. Finite stuff like finite sets and finitely presented groups are compact. Okay. Okay. But what is it? Okay. I guess it just means somehow all my modules are, yeah, I'm still trying to understand Arad's earlier comment though about something about why I want it's compactly presented by line bundles. That's what I'm trying to understand. What does it mean? Your claim was wrong. Okay, but the spiritual idea works. Okay. Okay. Yeah. If we go back, yeah, I think Drippity might be wrong here. I could, but maybe I made a mistake in my original attempt at constructing a ring automorphism out of F here. Every module is a colimit of line bundles, but the colimit may not be filtered. Okay. Merry Kris-Math. Mikhail, Merry Kris-Math. Like AB is determined by that for X compact. Okay. I still don't really get it. But I believe you anyways. Okay, the sequence should be split. This I agree with. Okay. Can this be generalized to non-commutative rings? And can you please be more specific about the map from aught R mod to aught R? Locally finitely presentable means a category is described by its finite stuff. Yeah, I mean, the idea makes sense to me, I guess. But what does it actually mean? Yeah. I mean, I guess it just means it's a colimit of the compact things, but... yeah. Look at for real. Okay. The regular right module is a projective generator. Sure. So then P should be a projective generator. Sure. Any such gives a ring. Right. So then, right. We get our projective, and we can look at the end of the projective. And, right. There should be equivalence to S. Okay. Induce map on endomorphism rings. Any module can be sifted as a colimit of finite free modules. Okay. Really? What does it mean to be sifted? As a sifted colimit? I don't know what that means. Is that the same thing as a filtered colimit? Okay, we always have a map from here to here. Yes. This is functorial. But this is isomorphic to R op, right? You know, if we did things on the left, if this stupid AI did things on the left, I don't think we'd have to put the op here, which would be better. Left modules are superior, actually, by the way, if you guys didn't know. If you disagree with me, you're bad and wrong. And you should feel bad on this Christmas day for believing in right module superiority, if you do. Just so you know. Sifted colimits are to finite products as filtered colimits are to finite limits. Okay. I'm gonna need to do some reading up on these terms on my own. Oh, I see. There does seem something special about the commutative case, perhaps, because of this claim. I'm pretty sure if we do things on the left, we can get away without an op, though. Determined by... Oh, it's so hard to read when it doesn't compile the tech. Ugh, it makes me want to give up. No, I mean, but this is... Yeah, I'm still pretty sure. Okay, maybe I'll come back to this and I'll do this computation again, because I'm still pretty sure that if one walks through this computation, it just ends up being the identity on R. Because where do you send R? R goes to, like, multiplication. R goes to what? Like, right multiplication by R. And then it goes to F of right multiplication by R. And then this goes to... Yeah, what's the map? Yeah, somehow, like, because basically this map is defined by the adjunction and this map is defined by the adjunction. And I'm pretty sure that what happens here and what happens here basically undoes everything, and you end up with and you end up back with R. I'm pretty sure that this like it's not surjective. F is an equivalence here. F is an equivalence of R mod, from R mod to itself. A filtered colimit of finite free modules is flat, so any non-flat module is a module which is not a filtered colimit of finite free modules. Right. Okay. I could believe that. That makes sense enough to me. Prefer to think of sifted as geometric realizations. Interesting. Well, well. What else is there? Okay, then we go into Picard group over the ring, blah blah blah. Not the same as classical Picard group. Okay. Yes. Where does ought R appear non-commutatively? This is what I'd like to know. The outer automorphism group. Wonder, can you please give me some resources for the non-commutative case? Yo mama's so flat, she's a filtered colimit. Yeah. You thought the confusion was that any module is given a filtered colimit? Oh, your thinking was if F is monoidal, then FR has to be R. Really? Interesting. You mean isomorphic to R, right? But probably by non-canonical isomorphism, right? Or maybe canonical. Autoequivalences. Yeah, give me... Wait, can you give me some papers here? Can you give me some papers here, Jippity? Wait, what's this button at the top? Why does it say perplexity? Wait, why does it say perplexity? Why am I not doing Jippity? Whatever. Oh, why? And now it's gone. This is like the time you spent an hour reading an LLM proof of an information theory thing just to conclude it had absolutely nothing. Yeah, fair. That could be true. It's part of the monoidal structure, I see. Non-commutative geometry. Oh, that might introduces categories like this? Okay. Okay, maybe that's what I want to look at. I should have known it would be in a non-commutative algebraic geometry thing. Yeah, okay. You're part of the monoidal structure? Yeah. God, isn't that what we're all hoping for deep down inside? Well, maybe I'll look at this paper. I'll search this paper for automorphisms, blah, blah, blah. Well, that'll do it for our Merry Kris-Math, stream today. So thanks for joining me. Yeah. You know, Q. ED.